Try tan negative theta times cos squared 180 degrees minus theta all over sin 360 degrees minus 2 theta. What's the first step? We have to identify our trig techniques. Tan negative theta, this is a negative angle. Cos squared 180 degrees minus theta, this is a reduction plus our trig. And in the denominator we have sin 360 degrees minus 2 theta, this is a reduction. Okay, step 2, let's apply our trigonometric techniques. Tan negative theta is in the fourth quadrant where tan is negative, so this should be negative tan theta. Times, we have cos squared 180 degrees minus theta. Let's apply our reduction. 180 degrees minus, that's 180 degrees minus. It's in the second quadrant where cos is negative, so this should be negative cos theta squared, because we have a 2 there, all over sine 360 degrees minus 2 theta. 360 degrees minus is in the fourth quadrant where sine is negative, so this should be negative sine 2 theta when we reduce. Okay, so for the next step we can simplify this part. We have negative tan theta times negative cos theta squared. Anything in math when squared is positive. I taught you guys in the grade 11 playlist in the trig video. So negative cos theta squared is positive cos squared theta all over. We have negative sine 2 theta, so you can just write it as negative sine 2 theta. Okay, so what's the next step? We can multiply our signs. Negative times positive is negative, so we can write our entire numerator as negative tan theta times cos squared theta all over. We have negative sine 2 theta, so we can just write it as negative sine 2 theta. This cancels with that, and we're left with tan theta times cos squared theta all over sine 2 theta. So, how can you simplify this? In our numerator we have tan theta, and remember our quotient identity states that tan theta is equal to sine theta over cos theta. So we can substitute that quotient identity. This will be sine theta over cos theta times cos squared theta all over sine 2 theta. To simplify our numerator, this cancels with that, and we're left with sine theta times, we had cos squared theta, we divided it by cos theta, so it's just cos theta all over, we have sine 2 theta. Sine 2 theta, I'll simplify that in a bit. For the ones that are a bit confused here in the numerator, I just want to remind you guys about the fractions. You have sine theta over cos theta times cos squared theta. This is basically cos squared theta over 1. So if you said this is sine over cos times cos squared, right? So if you have sine theta times cos squared theta, this will be sine theta times cos squared theta. And in the denominator you have cos theta times 1. This will be all over cos theta, because it's cos theta times 1. So this cancels with that, and you're left with this part, which is sine theta times cos theta, and it's that part. So you're allowed to cancel. That's how fractions work. Okay, in our denominator we have sine 2 theta. So we can just erase this and solve the numerator immediately. We have sine 2 theta. Remember, sine 2 theta is your double angle. Sine 2 theta is the same thing as sine 2 alpha. So this sine 2 theta will therefore be 2 sine, we have alpha, so we substitute this theta, 2 sine theta times cos, we have alpha, so this will be cos theta. Again, when you deal with trig, please make sure that all your information is available. Okay, so Right now we have sine theta times cos theta all over 2 sine theta times cos theta. This cancels with that, and this cancels with that. Your answer is therefore, in your numerator you have 1. So this will be 1 over, in our denominator we have 2. So what you are given here, tan negative theta times cos squared 180 degrees minus theta all over sine 360 degrees minus 2 theta is equal to 1 over 2. That is how we simplify that. So this could be a simplified question. In an exam, they might say, simplify this part. They could use it as a trig identity. They might say something like, prove that what you're given here, tan negative theta times cos squared theta is equal to a half. So when you simplify that, you'll get this part. And you'll see, therefore, the left-hand side is equal to the right-hand side. You guys should know how to deal with trig identities because I introduced them in the grade 11 playlist. Now let's move to the next question.